Hello, I am Farhan Shakil, and today we are going to talk about the Edexcel AS Level Unit 3, and that is about the waves, right? Which is, the syllabus, the part of the Unit 2 of this paper. So first of all, we're going to talk about the wave phase and the superposition, which is the topic 3B. First of all, if you're talking about the wave phase, so we have to keep this thing in mind that wave phase is an angle theta is equals to omega t, which determines the which determines angular displacement of an object, right? Which determines angular displacement of an object. And whenever you're talking about the superposition is that the overlapping of two or more waves. Whenever you're talking about superposition, it is the overlapping of two or more waves, right? And whenever two or more waves overlap, they either end up getting their amplitudes added up to get yourself the Y resultant, or in the similar fashion, they would either get their amplitudes cancelled up. It all depends upon, whether or where those two waves are overlapping. Now, getting back to the wave phase, you know, for example, whenever I'm talking about a wave, for example, you've got a wave like this. This motion of a wave can be copied in a circular path, something like this, where the body keeps on rotating in a circular path. So first of all, you've got this wave, and then you've got this wave. So first of all, when an object is at point A, in this wave, the object is also at point A. And when it starts rotating, and as soon as it reaches at this point, for example, this point to be B, the object gets to the point B somewhere over here. And then when the object gets to point C, it can be copied over here at point C. Similarly, when the object gets to this point D, the object in this wave gets to point D. And at the end of the day, when it gets back to the point where it started from, yani A, it is going to be A again. So by comparing this motion and this motion, we can also talk about the phases, the angles. So when the object was at A, the phase was 0 degrees. When the object got itself at B, the phase got 90 degrees. When the object got itself to C, the phase got 180 degrees. When the object got itself to D, the phase got 270 degrees. And when the object got back to A, the phase got 360 degrees, meaning thereby a complete cycle have been achieved. Now, coming to the important part of this topic, that is the relationship. Whenever you're talking about it, that is the relationship between the phase difference. That is the relationship between the phase difference and the path difference. We just need to talk about that. What is the relationship between these two kind of topics? So you've got the phase difference and then you've got the path difference. For example, first of all, you've got this wave, something like this. You can see that an object initially is at point A, an object then is at point B. And now somebody is asking you to calculate the phase difference, the difference of the angles between the object at A and at B. So now we got to talk about the phase difference. So first of all, the phase at A is, everybody knows that it is 90 degrees. And the phase at B, everybody knows that it is 270 degrees. So it is going to be 270 minus 90, and it comes out to be 180 degrees. That is how we calculate the phase difference, right? So that is how we calculate the phase difference. Secondly, if you want to get yourself the path difference between the same points, you can also remember the formula that the phase difference, which is represented by delta phi, it would always be equal to lambda divided by 2 pi times delta x, where delta x is the path difference. So for example, if you're looking for the path difference and you've already got the phase difference, which is 180, in radians, it is going to be pi. Okay? So delta phi, the formula for the delta phi is going to be something like, you must be having it 2 pi upon lambda times delta x, right? So delta phi is already pi. equals to 2 pi divided by x times divided by lambda times delta x. And now you can eventually work out the thingies. So delta x comes out to be pi times 1 upon 2 pi times lambda equals to delta x, right? So pi cancels out and you would end up having lambda by 2 equals to delta x. So by this formula, we can have the relationship between the phase difference and the path difference. So we need to remember this formula as well. And that is how we're going to answer any question regarding the phase difference and the path difference in this topic. Thank you very much. For more videos like this, please comment, like, and subscribe the channel. Thank you very much.